Okay, so welcome back to the channel. Today we are going to solve this reverse linked list problem. And this we know, like all the FANG companies and all the smaller company or the startup, everyone asks this questions, right? This question. So this is really important question to solve. So the problem is given a head of the singly linked list, reverse the list and return the reverse list. So we will be coding in Python basically for the data engineer or for the data science role. We generally code in Python, right? So we will be solving this in Python. So here, if you see, basically the input would be like this. So we have the class list node where we will have the node, right? So val, which is nothing but the value inside the node, and the next, basically to which this particular node is pointing. So one is pointing to two is pointing to three. So for each and every node, we will have the next pointer. That is how the linked list is made, right? So in this problem, we have been given 1, 2, 3, 4, 5, and the output is 5, 4, 3, 2, 1. So basically, if you see, the direction has been changed. Earlier, the one was pointing to two, but if you see in the final output, the two is pointing to one. Same way, four in the input, the four is pointing to five, but in the output, five is pointing to four, right? I think you got the point. So in our solution also, we just need to reverse this direction, right? So for the given input 1, 2, 3, 4, 5, the output is 5, 4, 3, 2, 1, right? And similarly for 1, 2, the output is 2, 1. And if the head is null, basically there is nothing. So in that case, our output would be a null only, right? So to solve this, we will be having this function, um, a reverse list in which we will be having head and we need to return the head only, right? Or basically the linked list pointer, which is pointing to the head, where from where the we can basically print this, right? So this is what the input and output is. And if you see this follow-up, a linked list can be reversed either iteratively or recursively. Could you implement both? So we will be trying to implementing both the solution, right? Now let's jump to the uh, whiteboard and try to solve this. Okay, so let me take this. So let's say we have 1, 2, 3, 4, and 5. So this is the linked list we have, right? And head, we know head is pointing here, and this is the last. So this is none, basically, right? This is pointing to none, and we need to reverse this, or basically we need to change the direction. So I will write like this only, 4, 5, right? And what we will do is we will change the direction. So this, this, this. So when we return, we will return this pointer or we will return this. So this we will return, and this will have basically none. So this is what the output would be from this given input, right? So let's see how we can solve this. Let me recreate this. We can write 1, 2, 3, 4, and 5. This is none. So this you can write as head. Okay. So to solve this, the approach would be before we basically reverse this direction, right? Before we reverse this direction, we should have something to hold over here, right? So let's say if I flip this to this direction, right? I should not lose this. So we should have a next pointer basically, or and okay, let's write like this because next is internally getting used to point. We can use as next pointer np, right? And so as of now, we will make this as np, and for this one, we should have the previous also. So we can use a pointer as previous. So previous, like this, right? So this is how the approach would be. To reverse a linked list, we need three pointers. We need three pointers. One is head, another one is next pointer, another one is previous. So for each and every node, what is the previous and what is the next, right? So let's start solving this. Okay, and this is pointing to none. So as I mentioned, we will have head h, and we will what we will do is we will create a previous pointer. So previous initially would be none, right? Would be none. So previous is over here, and what we will do is we will run a loop. So we are solving this as of now iteratively, right? Iterative approach. So while head is not none. So till that point, we will run this loop till head reach this point. So what we will say, again here we are writing previous equal to none, right? Previous is over here. Then what we will say, we will again before shifting this direction or before swapping this direction, what we will check is if we have head, if the head is not none. Okay, so head is not over none over here. Then what we will do to point to the next pointer or to hold the next point, what we will do, we will say next pointer np equal to what np would be head dot next head dot next. So here NP would be coming. Now NP is holding this data, right? NP is holding this data. And now since we have uh, the hold of forward data, what we can do is we can change this the next of this head. So what we can do is we can write head dot next is equal to, so what is the head dot next? We need to reverse the direction, right? From this direction to this direction, we can put none over here. That is previous, right? And again, now everything is done for this. So now how the linked list is looking like? The linked list is like this. This is the current position basically. Now the next what we want is we want now we will be shifting this head to this, right? Because in the next iteration now the head will become this, right? So before we shift this head to the next pointer, we need previous to shift to the head pointer, right? So we will do is previous equal to head, and now the position is like this. Here we have previous, and now we need to shift the head to the next pointer, because for the next iteration this will be head. So head equal to next pointer. So wherever the next pointer is, so next pointer over here, this. So this is what the position is after the first iteration, basically, right? Now, again, this we will move forward. So head is not none. So over here, till over this point, head is not none, right? So NP will move forward. So NP will come over here, NP, and we will erase this. Again, the same process, this keep on happening. So head dot next. So head, since we have the next point or the data holding from this to this, so what we can do is we can point to this, right? So this is what is happening. So head dot next. So in this we are breaking this pointer, and we are pointing head dot next to this, and now again previous needs to move to the next pointer, right? So previous now become this previous, and head will go to here, head, right? And we can remove this, and let me erase this also. This is what the current position is. Now again head will go over here, right? And not the head, basically next pointer over here is like this. So next pointer will be here, head is still here, and again same thing, we will make the previous connection, we will break this connection, and we will point this head over here and previous over here. right? So this is the current position. Now we have this holding basically. So again, what we will do, next pointer, this will move to here. So here we have the next pointer, and head dot next we will make like this, and then this done. Then previous is equal to head. So previous from here it will come here. So this is previous, and head will again go from here to here. So head is here. Let me clean this now, right? So our current situation is this. This is previous and head, and so before the loop start, the position will always remain like this. Head and next pointer will be here at this line basically, right? If head is not null, then what will happen? Um, Next pointer will go to none. So basically here the next pointer will be here, and this we will break, right? And then head dot next equal to previous. So this direction will be changed, right? So with this code, we are basically changing the direction, change direction. And these step are the helper. These three line are helper for the future, right? So now this is the position as of now. So next what we need to do is direction is changed. Previous is equal to this. So previous will come over here, and head will be here. Again, head is not none. This is not true. Head is actually none. Then what we will do is we will return. Okay. Uh, okay. So what we will do is we will write over here outside this loop is return previous. Why previous? Because previous is holding basically, previous is holding the next point, basically the head, whenever the head is becoming none, right? So that's why we will be returning previous from here. So I hope you understood. So if we talk about the time complexity and space complexity, so time complexity, it is O of n, right? And space complexity, are we using any space? No, I think we are simply iterating. So space complexity would be O of 1. So yes, I think we solve this problem using the iterative approach. So you can see the code, right? This is the code. Let me uncomment this. Same, right? And here we have the spatial case. So if head itself is a none, then we need to return this, right? So let me run this. This is the recursive approach. Let me comment this first and run this. Okay, this got passed, and let me submit this. Okay, this got accepted, right? Now, let me comment the iterative approach and help you to solve in the recursive way, how we can solve this in the recursive way, right? So I will explain the code. Basically, the same code is there. It's just that we are not using any loop. We are using a recursive function. So what we are doing is, this is the code. So we know this remains the same. If head is none, we need to return it. And same thing. Um, if you see, this piece remains the same for the recursive. So we are creating a previous pointer, right? Previous we are initializing as none, and we are passing, and head remains the same. So this function, recursive function, is getting called. Again, this remains the same. If head is none, if we are reaching to none, then we are returning previous. Same we were doing over here also, right? If we are if head is becoming none, then we are returning previous. Same thing. So we know, right? For the recursive, we have this as a base condition, right? So this becomes the base condition from this loop, right? Head is none, return previous. Same thing over here also we are doing. Again, the the middle part remains the same, right? Middle part remains the same. And again, instead of basically writing the loop, what we are doing, we are calling this function again, right? We are calling this function again. So basically, let me explain over here. So how this recursive function is working. 1, 2, 3, 4, 5. So what we did is, let's call as recurse function. What we did, we provided previous equal to none. So here previous was there, and then we had head, right? So this head and previous, we called on this in the first iteration. Again, in the next iteration, what we are doing is we are providing previous. So this would be the previous, right, in the next iteration. And let's say we are at the point where head is this. So and this direction would be changed, right? So and this will not be there. So this is how we are basically calling this previous next, or previous head basically, right? So that is how we are solving this problem via the recursive approach. The code remains the same. It's just that instead of basically returning after the iteration of the loop, we are returning over here as a base condition, and then we have this, and then this is the recursive part, which is calling the function again, right? So let me submit this. Yes, this got submitted. So yes, if you like this content, please do like, subscribe, share the channel. Let's meet in the next problem.